Hello everyone, good evening. This is Balaji Avaru, a member of the talent management team at DDS Analytics. Over this presentation, I will take you through a brief overview of employee attrition analysis and how we can minimize it going forward. We will also look at models to predict monthly income. Let us go over some of the preliminary analysis gathered on the data sets. We have been provided 870 employee records with 36 columns. For the purpose of classification, whether or not an employee is likely to quit, we use column attrition. The dataset is unbalanced dataset. The dataset contains 730 records with a no response and 140 records with yes response. For modeling purpose, we have balanced the dataset by upsampling such that we have an equal number of records for each classification. There are so many variables in the dataset such as age, business travel, daily rate, department, distance from home, education, etc. Explanatory data analysis. By looking at the dataset, variables like over 18, employee count, standard hours are having the same value for every row. We can eliminate these three columns. We also see that there are numerous variables seen as integers, which should have been as factors. We converted these variables as factors. Now let us look at the factors that have most impact on attrition. Overtime, stock option level, job involvement, job level, marital status were shown to be the factors that have most impact on attrition. These factors were chosen by using a chi-square test to test for significance with 95% confidence. Variables such as gender, education, daily and hourly rate, monthly income, performance rating, relationship satisfaction, and time allotted for training were not significant impact on attrition. Looking at the job specific roles, it seems that with the leadership role like directors, managers and executives have lower attrition rates than those who work under them like representatives, technicians, research scientists. This holds true for overtime as well, since the leadership roles do not qualify for overtime, have a much lower attrition rate compared to those who do qualify for overtime in non-leadership roles. Attrition rates are highest with employees who have no stock options or who have the most amount of stocks. Looking at the attrition rate for divorcees versus the employees who are married or single, the divorcees have the lowest attrition rate at 6.28%, while those who are married have a attrition rate of 14.15%, and the single employees have an attrition rate of 26.02%. Now let's go over prediction models for attrition. We have decided to use logistic regression model. This will allow us to split our data into training set and test set. We will build the model with the training set and test the model's ability on the test set. Whichever model giving us at least 60% sensitivity and 60% specificity will be the model we will go with. We built three models. Model 1 with all variables included in the model. Model 2 removed variables that had highest correlation with other variables. And model 3 removed all non-significant variables. Model 3 had the best specificity and sensitivity. This will be model we go with for predicting attrition. Now look at attrition by job role. Looking at the plot of attrition by job role gives misleading inference, indicates less sales executives, research scientists, and laboratory technicians have highest turnover by count. If we look at percentage attrition by job role, we get a different picture. Looking at this way, we see top three turnover job roles are sales representatives with 45%, human resources at 22%, laboratory technicians at 20%. Now look at monthly income regression models. Looking at the prediction model used to estimate monthly income from the validation file you gave us, we have decided to use one of three models to do this. In order to do though, we need to find out how many variables to use to predict monthly income. This can be a tedious job. So we used auto selection models such as forward selection model, backward selection model, stepwise selection model, which give us number of variables it can use in order of the best p-values according to monthly income. The model will give us RMSE each time it adds a new variable. RMSE is basically just the standard deviation of the residuals. So we want that number to be as small as possible. At some point, the RMSE will cease to decrease and begin increasing. This is the sweet spot. In terms of the number of variables the model will use, whichever model has the lowest RMSE, the model we will go with. After running the model through the training data we were given, it has been determined that the forward selection model has the lowest RMSE at around 15 variables as seen here. The RMS at 15 predictors is 948. We will use forward selection model to predict monthly income for validation file. Conclusion: attrition can be classified with a model that has accuracy of 86%, sensitivity at 85, and specificity at 86%. There does appear to be a pattern of high turnover in the following jobs: sales representatives, human resources, and laboratory technicians. Monthly income can be predicted with a model that has highest accuracy with R square of 95% and RMSE of 948. Thank you very much for the opportunity.